In this lesson, I'll introduce the idea behind binomial probability, which is the probability of observing a certain number of successes compared to the overall number of trials in an experiment that has just two outcomes, either a success or failure. Examples of experiments that have just two outcomes are shown underneath. The very first one that I've illustrated is flipping a coin. When you flip a coin, you can have success being heads and failure being tails. Another example is rolling two dice. In this case, if you roll a total of, let's say, 2, that could be considered a success. Rolling a total other than 2 is a failure. We also see this when we test a computer chip. A chip that functions properly is a success, and one that is defective is a failure. Inoculating a person with a vaccine. If the person becomes immune after taking the vaccine, that's considered a success, and if the person does not, that's a failure. What about buying a box of cereal? If you obtain a new collectible item, such as a toy, that's a success, whereas a failure would be that you obtain something from the box that you already have. And lastly, another example is when you guess at a multiple choice question. Guessing correctly is considered a success, whereas guessing incorrectly is a failure. Like any experiment, binomial experiments are made up of multiple trials, referred to as binomial trials. These experiments have the following properties. For example, the experiment is performed for a fixed number of trials. The experiment has only two outcomes, success and failure. The probability of success is the same from trial to trial, and the trials are independent of each other. Let's look at examples that are not binomial experiments. The first one being rolling a single die until 6 comes up. So why isn't this a binomial experiment? Remember what I said, if there is not a fixed number of trials, then it is not a binomial experiment. Because you don't know how many times the die will need to be rolled before a 6 comes up, we can't define the number of trials. Another example of one that's not is a student takes a course and earns an A, B, C, D, or F. Because there are more than two outcomes, then it's not a binomial experiment. And lastly, select 4 cards without replacement and observe whether a heart is drawn. Because the cards are not being replaced, the probability of obtaining a heart after selecting a card will change from draw to draw. Because the probabilities are not consistent from one trial to the next, then it's not a binomial experiment. So now that you understand what a binomial experiment is and how it relates to binomial probability, make sure to watch our upcoming video where we discuss how to compute the binomial probabilities. Talk to you soon.